yesterday we heard a very good talk from Dr. Rogers. And after his talk, I decided to get up early, 2 a.m. this morning, to change my transparencies. In Rogers' talk, he mentioned that the most important issues in the PC study USA intensity, size, and genesis problem besides track. And relatively, there is little attention has been put in QBM. However, in Taiwan, the story is quite different. Here I put on some track, the track of some typhoons which cause serious disasters in Taiwan. And here is the typhoon name and the death or injuries numbers. And then the maximum intensity and the rainfall here. And we can see that strong typhoon always cause serious damages. However, serious damage could be caused by weak typhoons or even by a tropical depression, such as Typhoon Tsunami, which Hongji just mentioned about. When tsunami brought about more than 300 millimeter rainfall in Kaohsiung, caused quite a lot of floodings or tall buildings. It was already a tropical depression. So QBM or rainfall issue is the most important one in Taiwan. So that is also the major focus of Typhoon and Flood Research Institute. Here you can see that typhoons have all kinds of competitive aspects. So to solve this problem, when I was at NCD, the National Center for Disaster Reduction, we tried to develop a typhoon rainfall model. And this, as we all know, that the typhoon rainfall may be occurred due to the first one is convergence of typhoon circulation. It's a radius dependent. And also torrential lifting or typhoon circulation, that's location dependent. And the convections within IWO and remnants, that's transient. That's the most difficult part. Okay. Also, interaction with environment, such as northeastern monsoon and southeastern monsoon, which Hongji also mentioned about. And the torrential lifting or typhoon circulation makes the use of chronology model for typhoon rainfall focus feasible. Okay. So we can call it topography lab. And this has been published in one of our papers in 2006. And our model can provide hourly rainfall amount and the cumulative rainfall when integrating along the typhoon track. And we all know that right now, such as Central Weather Bureau, they use ensemble focus for typhoon track. That's much better than a single model, such as right now as CWB, the 24-hour forecast area is about 100 kilometers, but the model area is about 140 or 50. Okay. However, if we look at hourly rainfall, the area is large. However, if we look at the cumulative rainfall, it is not too bad. That's for one case. And our model can also provide rainfall estimate around the whole island during typhoon periods. So this model depends only on the track or the typhoon. That's our origin. Okay. And let's look at this is the information which we provide to the Water Resources Agency before the typhoon make rainfall. That's in 2008. I always also have for 2009, but not here. Okay. Here's the observation, and this is estimated by our rainfall model. And this is these different river basins. And these are 24-hour time periods, and these rainfall periods. So these data are right before typhoons are making rainfall. And it turned out to be that for some river basins in that northern basin around Taipei, not so good. However, for central to southern Taiwan, the result turned out to be not too bad. Even for one case, the observation is 399 and our estimate is 100. We might be cheating. Okay, that's possible, but not to be. But you can check these data were provided to the Weather Resource Bureau before typhoon make rainfall. Okay, so here's a summary of our typhoon rainfall model. Okay, we call it version 1. It's a purely climatology, so it depends on hourly position only. Yesterday was mentioned about this model it does include the time moving speed because we count the rainfall every hour. So for a slow moving typhoon, okay, you will stay at the same place longer. And this model is developed at NCDR when I was the division head at NCDR. Okay. Also, this is the version which CWB is using. And during the last 1 to 2 years, we try to improve this model by considering the effects of track intensity and size. So we can solve the serious underestimated problems for climatologists. But this one is mainly for river basin because this project was funded by Water Resource Agency. And this one is developed at NTU. And currently, at NTU and at TDFRI, okay, we try to use the satellite rainfall climatology